Assalamualaikum, my name is Ahmad Danish, bearing the student ID of A201317. And let's dive into question number 1. Final assessment. Question number 1, chapter 3, AC network analysis. So it gives us this figure, then it asks us to propose a circuit that yields the result in figure 2. For those metric number ending with odd number, please use resistor and capacitor. So the time is in millisecond. So the unit is in milli. Hence why 125 times with 10 to the power of -3. And then we sub into the frequency formula, f equals to 1 over t, and then we get 8 hertz. And then for omega, we use omega equals to 2 pi over t. We sub in the value, and then we get 16 pi. Then this is a high pass filter because as we know that capacitor blocks low pass filter and it allows high pass filter. And then for resistor, it doesn't block low or high pass filter. Hence why this circuit is a high pass filter. Okay, because capacitor blocks low pass filter. Okay, and then we use V out equals to R over ZC plus R times with Vn. Just a simple calculation. Just simply a voltage divider. Then V out over V in equals to R. And as we all know, ZC equals to ZC is equals to 1 over JWC. Okay, and then we sub in the value, and then we let capacitance C equals to 0.1 microfarad. Okay, and then once again we sub in the value to find R. And then we get R 149.2 kilo ohm. So let's dive into LT Spice. First we have to open our LT Spice components, look for voltage, and then we need a capacitor. We need to rotate it. Rotate the capacitor, and then we need a resistor. And then we connect all these components, and don't forget the ground. We need to connect this too, right? And then we sub in the value for capacitance. Capacitance is 0.1 microfarad. The resistor is 149.2 kilo ohm. 149.2 kilo ohm, right? Then click advance, look for sign, offset is 0, Q is 5, frequency is 8 according to the calculation, and then the degree is 90. Then we click on this running man to run this circuit. Stop time, we put 10. Then we have to click on V input and V output. And then we have to zoom in because this is too much. We have to zoom in, and voila, we get this graph just like the figure 2. So you can see the V output is the blue one, V input is the green one, which has the amplitude of 3 volts for the blue one and 5 volts for the green one, respectively. So that's it for question number 1. We need to, alright. Let's dive into question number 2. Chapter 5, Frequency Response. So it gives us this figure 3, which is a band pass filter. The idea is that it allows low frequency and high frequency, and it blocks the medium frequency. Hence why the band pass filter looks like this. And then we have the value of FL, FC, and FH, which is 1 kHz, 5 kHz, and 10 kHz respectively. We have to propose a circuit to yield the result in figure 3. For those metric number ending with odd number, please use resistor and inductor. So let's look at this circuit that I proposed and the calculation. Load pass filter, I assume that the inductor is equal to 0.5 Henry or only. We've used the formula FL equals to R over 2 pi L. We sub in the value, then we get the value for R, which is 2513 ohm. For high pass filter, H is equals to R over 2 pi L. We let L equals to 0.5 only, and then 10,000 equals to R over 2 pi times 0.4. We sub in the value, and then we get R equals to 25.1 kilo ohm. Oh, and then we use this formula, as you can see, 20 log base 10, the out will be in modulus equals to dB, which is equals to -3. Why? Because according to this figure, it's equals to -3. Oh, sorry. Then we sub in the value. Once again, we sub in the value. We get this 10 from log base 10. Then we sub in the value, and then we get L equals to 0.40 only. For high pass filter, we let R equals to 25.1 kilo ohm. Use the same formula, then we just sub in the value once again, equals to -3, and then we get L equals to 0.20 only. This is for inductor 2 and this is for inductor 1. So let's make a circuit. Let's dive in right into the spice component, voltage, first we need voltage, and then we need a resistor, rotate it, and then inductor, rotate it once again, then resistor, and then inductor. Then we connect all these components. Just like that, and don't forget ground. And we need to connect this ground to right. And then we sub in the value. R1 is 2513 ohm. Inductor is 0.40 only, or Henry. And then for R2 it's 25.1 kilo ohm. For inductor 2 it is 0.20 only. Voltage, we click advanced, click for sine, amplitude 1, frequency is 1, And don't forget to click on AC amplitude. It's AC1. You have to type AC1. Then we don't have to click on this running man yet. You have to simulate. Edit simulation. Click on AC analysis. Type of sweep is decade. Start frequency is 1. Stop frequency is. Put a big value to have a picture of it. Okay. And then we can hit on this running man to run this again. Then we get this band pass filter, which is the same as the figure 3. So that's it for me for the final assessment. Thank you so much.